Hi everyone, the question is, let a1, a2, a3, a4 be real numbers such that a1 plus a2 plus a3 plus a4 equal to 0 and a1 square plus a2 square plus a3 square plus a4 square equal to 1. Then the smallest possible value of the expression a1 minus a2 whole square plus a2 minus a3 whole square plus a3 minus a4 whole square plus a4 minus a1 whole square lies in the interval. So here let's first expand the expression which we want to minimize. We want the smallest possible value of this expression. So here this essentially turns out to be what? You'll have 2 times a1 square plus a2 square plus a3 square plus a4 square minus 2 times you'll have a1 a2 plus a2 a3 plus a3 a4 plus a4 a1. Now a1 square plus a2 square plus a3 square plus a4 square is 1, it is given to us. So what we get is 2 times 1 is 2 minus 2 times, and if you see carefully, this a1 a2 plus a2 a3 plus a3 a4 plus a4 a1, it can be factorized where you can take a2 common from the first two terms, and the factor that you get is a1 plus a3. And similarly in the next two terms, or you may say last two terms, you can take a4 common, and the other factor that you get is a1 plus a3. So essentially this expression is a2 plus a4 multiplied by a1 plus a3. Now here if you see carefully, a2 plus a4 is minus times a1 plus a3. Why? Because a1 plus a2 plus a3 plus a4 equal to 0. So essentially it becomes what? 2 plus 2 times you will have a1 plus a3 whole square. Now for me to minimize this expression, because that's what the original expression turns out to be using the given other informations, you can say the minimum possible value of this expression is 2. Given that a1, a2, a3, a4 are all real numbers, so the minimum value of a1 plus a3 whole square is 0. So that means the minimum value of this resulting expression, which is same as the original expression, is 2. Now this will happen when, is it even possible to have this minimum value 2? So you can say that this will happen when a1 plus a3 is 0. That means what? When a3 equal to minus a1. So here if a3 is equal to minus a1, that means a1 plus a2 a1 plus a3 equal to 0. That also means a2 plus a4 equal to 0. Why? Because a1 plus a2 plus a3 plus a4 equal to 0 is given to us. So that means what? a2 plus a4 is equal to 0. So that essentially means a4 is equal to minus a2. Now if you put a3 to be minus a1 and a4 to be minus a2 in this sum of these squares being 1, this equation, you essentially get what? You essentially get 2 times a1 square plus a2 square equal to 1, or that means a1 square plus a2 square is equal to half. So there are infinitely many such possibilities for which you can have a1 square plus a2 square being half, and the moment a1 and a2 are fixed, a3 and a4 automatically get fixed because a3 equal to minus a1, a4 equal to minus a2. So this the later part of the solution is just to convince ourselves or to explore further whether the minimum is actually being attained, and when or for what conditions is this minimum value actually being attained. Nonetheless, the minimum value is 2, and this lies in the interval 1.5 open to 2.5 open. B is the answer. Thanks for listening.